Chapter 4, Exercise 4.52. Enter a formula for the compound that forms between beryllium and each polyatomic ion. A beryllium atom loses 2 electrons to form beryllium 2+ in an ionic compound. The polyatomic ion will have to accept the electrons from beryllium. For example, in this case, chromate. Chromium is a transition metal, and transition metal often have different oxidation states. That means they can bear various charges in this polyatomic ion or as a cation. So over here, I would say you can search for the structure of chromate. In this case, we have 1 chromium and 4 oxygen atoms together with 2- charges. So this polyatomic ion has 2- charges, and Be beryllium has 2+ charges, and therefore they cancel. Why 2- charges on this polyatomic ion? So if you look for chromium in the periodic table, you will see chromium is argon plus 4s2 3d4. There are 6 valence electrons. So in this structure, chromium may lose all 6 valence electrons, and then we have chromium 6+. Each oxygen is 2-. We have 4 such oxygen ions. So we have A-, A-, 6+. We have a 2- charges on this polyatomic ion. Again, it's called chromate. We'll submit. This is the chromate ion. We have chromium 04 with 2- charges. Sulfite. We have sulfate versus sulfite. Sulfate, ATE, that's SO4 with 2- charges. This is sulfite, SO3 with 2- charges. Alright, so it's SO3 with 2- charges. Beryllium has 2+ charges, so it's balanced. Part C, hydroxide. Hydroxide is OH- with only -1 charge, but beryllium has 2+ charges. So beryllium, we need 2 OH-. So while the name is hydroxide, we write OH with O in front of H. Part D, nitrite. There's nitrate, there's nitrite. In nitrate we have NO3, in nitrite we have NO2. Both bear a -1 charge. So over here we have NO2 with -1 charge. Right, NO2, and we need 2 nitrite to balance the +2 charge from beryllium.